All right, hey guys, Mr. Kyle Myers Mathematics, and this problem is crazy. So I actually did another, normally I just do one video because why ever do more than one or anything like that? Anyways, but I started to do this problem thinking like, oh, no big deal. Like the last few have just been super easy. I can just kind of like see it for the first time and go through it. But I failed to find an explicit formula for like the first couple minutes that I did the first video take of this, and it's crazy. I don't know if I have a really good answer for why I ended up finding out the answer to this. I ended up finding out the answer to this, but it's a little crazy how I ended up doing that. So I don't know if I have a really good answer for this, but basically what I did that finally allowed for me to get the answer was I was like, okay, um so there's we know that if it's a geometric series, then it would be a sub n equals a sub 1 times r to the n minus 1, right? And then the common difference would be just what you're timesing by each time. We know we're timesing by 2 each time, so we know our explicit formula for this should have something in the way of 2 to the n minus 1, or 2 to the n of some kind. It should have a base of a 2. But it's also arithmetic because we're adding 1 each time. Well, if it's arithmetic, then it would be a1 plus the common difference times n minus 1, right? And we know the common difference is 1, so it should just be n and some things. Some other things going there. So we know we've got to have an n, and but then we also have like a 2 to the n minus 1. But really the major thing that's happening is that we're doubling it. We're also adding 1 to it, but we're doubling it. So it's like the main thing is the exponential part of it, the geometric series part of it. So what I did was I said, okay, well, let's just look at what's happening after 0, because 0 is a little funky. And also they said n greater than or equal to 2. And notice on the last few questions, they like started out at 1. This one starts out at 2, and it does that for a reason. You'll see why in a second here. But if I say y equals 2 to the x, then that would be like this. I would say, let's start at 1. So 2 to the first power would be 2. 2 squared would be 4. 2 to the third is 8. And so on and so on. Well, if I minus 1, I get 1. If I minus 1, I get 3. Minus 1, I get 7. So I actually just need to minus 1. And that should actually do the trick. It's weird because the pattern is that it's like times 2 and then you add 1. But if I just minus 1 to everything, then that actually kind of fixes it a little bit. So if I say a sub n is equal to 2 to the n minus 1, let's see what happens here. So n and a sub n, when n is 1, then that would be 2 to the 1 minus 1, which is 2 to the 0, which is 1. Okay. When n is 2, that's going to be 2 to the 2 minus 2 is 1. 2 to the first power is 2. If it's 2 to the 3 minus 1, that's... Oh, hold on. Did I say something wrong? Yeah. So 2 to the 3 minus 1 is 2 to the squared, which is the 4. And so I'm getting a number that's a little bit bigger than what it should be, right? And so if I just minus 1 to that, then this would have been 0, right? So like n being 1, 1 minus 1 is 0, 2 to the 0 is 1, 1 minus 1 is 0, okay? Then if I plug in 2, 2 minus 1 is 1, 2 to the first power is 2, 2 minus 1 is 1. Plug in 3. 3 minus 1 is 2, 2 squared is 4, 4 minus 1 is 3. All right, let's keep going. Make sure the pattern keeps holding here. So 2 to the 4 minus 3, 4 minus 1 is 3. 2 to the third power is 8, 8 minus 1 is 7. Okay. Let's do one more. 2 to the 5 minus 1, 5 minus 1 is 4, 2 to the 4th power is 16, 16 minus 1 is 15. Okay, I think we're good here. So we found it, but it's a little crazy. You kind of just have to. What I basically did was I stopped the video and I was like, okay, let me just like switch hats for a second and just put on student hat and then just kind of like went at it and just tried a bunch of things until it worked. And so I'm sure there's like a method by which you can find out what the answer is, but better minds than me. Better minds than me, because I just kind of like tried some things until something worked, basically, is what I did. I did the shotgun approach. Try everything I know to try. So I wish I had a better answer, but this one was actually pretty tough. I actually had to think a little bit on this one. So yeah, hope that's been helpful. If you do know of a better way to do this one, let me know. I'd love to be privy to that information. But otherwise, I'll catch you guys in the next video. Hope that you guys have a good one. And I'm finally caught up. I'm finally caught up on all I was a couple days behind, so now we're caught up on the series on series. And yeah, so check out my website, Myers Mathematics, where you can find the 5 math mistakes everyone makes and how to avoid them. And I'll catch you guys in the next video. Blessings, y'all.